Hey, what's up? Welcome to this new video. This one is paper 3-2 of A-Level Math for June 2021. Again, this was sent to me by one of the subscribers. I don't know if that's exactly the paper. You can let me know in the comments below. However, let's move on to the question number 1. So here we have to solve the inequality. As we can see, we have modulus on both sides. So usually in that case, I always recommend to square both sides. So you can cancel out the modulus. That will become 2x minus 1 square less than 3 square will be 9, and then x plus 1 square. Now we just have to simplify, expand, and all that. Let's try one by one. Here we will have what? This will become 4x square minus 4x plus 1 less than 9, and that will be x squared plus 2x plus 1. Simplify. So again, same thing over here. We just have to expand the brackets on the other side. That will become 9x squared plus 18x plus 9. Now let's send everything to one side. Let's send everything over here. You will have 0 here less than 9x squared minus 4. That will be 5x squared plus 18 plus 4. That will be plus 22x plus 9 minus 1. That will be plus 8. So this can be rewritten as what? We can write this as this plus 8 is the same thing as saying, so 0 is less than this. This has to be more than 0. So same thing as saying this. So now we have this. Now again, we have seen this many times in math, I believe, right? To solve these kind of question or these kind of inequalities. So first we have to find the critical values of x. So let's equate that same equation to 0. That will be this plus 8 equal to 0. Now this one is a simple quadratic equation. We can either factorize or solve by using your formula. So I guess I will go with factorization. Why not? Have 5x squared and x here. Now 8 is what? 8 is 1 times 8, 2 times 4. Now obviously you have to choose a pair. You can choose this one or this one. In this case, I will choose this one because I need to have plus 22. So I'll put 4 here and 2 here. Now we always multiply in this way. This multiplied by this, and this multiplied by this. So here we need plus 22. So here 5x times 4, that will be plus 20. And then plus 2, that will become plus 22. Now let's solve. X will be the value of minus 2 over 5. X will be minus 4. So what is minus 2 divided by 5? That will be minus 0.4. Now these are not the answer for the question. These are the critical values for my equation. Now to solve this or to find the answer, we have to use a graph, for example, to understand what are we looking for. This is the line 0. And here, because here it is positive 5, we know the shape of the graph will be something like this. This will be the critical values. This first value here will be minus 4, and here you will have minus 0.4. Now, the condition needs to be more than 0, so we're looking for this side and this side above 0, so x will have to be less than minus 4 first. X has to be more than minus 0.4. So these will be the set of values for x for which this inequality makes sense or satisfies each other. In this equation, satisfies itself. That will be question number 1. Let's move on to question number 2. On a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequality. So we have this here, and we have this. So let's look at this one first. First we have z plus 1 minus I modulus less than equal to 1. So I think through experience and practice, you do realize this will be what? Will be a circular plane that we have to form, or solid circle. Let me see how can we rearrange this to know exactly where is the center and what is the radius of that circle. So that will be what? So z. We have to change this to minus, so minus. So the inside here will be minus 1 plus I, if that makes sense. So from this we do realize we have to draw what? We have to draw a circle, and the center is, the point will be minus 1i, and the radius is equal to 1. This value here is the radius of that circle. Okay, that is the first part. Now for this one, the argument of z minus 1 less than 3 pi over 4. Now again, you can always find the value first. What is the angle here? 3 times pi is 180 divided by 4, that should be 135 degrees. Just an idea for you of what is the angle we have in this case. Now let's rearrange. So again, we have to write this down as this. So we have z minus, obviously we like minus in this condition when we have to draw arguments or modulus of the complex numbers. And here we have to kind of find the point will be 1 plus 0i. This will be the point. From that point, the argument will be this. So the point, from that point, that will be 1 and 0i, and the argument value have to be, the angle value is this, the angle, right? Now let's draw the two separately first to have an idea what's going to be, and then we have to join them together and see where they meet. For example, if I were to draw this, that will be my vertical axis. This is the horizontal axis. This will be my real axis, and this will be my imaginary axis. The point here, center, will be minus 1. Let's call this minus 1. And I will be somewhere over here. And that should be a circle, center, this, radius 1. So radius 1, that should be 1. For example, that will be 1 here, and 1 here as well, for example. If you join them, again, you can always use your compass to do that, right? So this will be the radius. And now this is a circle. Again, here we have less than or equal to, so this is the maximum. Less than will be also the values inside, so we have to shade it. Okay, that's how the first one will look like. Now for this one, same concepts. That will be this, and we have this. For example, that will be my real, and this is my imaginary. Here the point is 1, so let's say 1 is here. And we know the angle from this line to go, the angle has to be 135. So 135 have to be what? We know that 135 is simply 45 plus 45 plus 45, right? So vertical line, for example, that will be 90. So we have to add 45. Now 45, we know exactly it is the half point. So if this is 1, then have to be, let's choose 1 as well. So we know this will have to be 45 as well. That makes sense. So 90 plus 45 will have to be 135, and this is the argument that we're trying to find or to draw for this line. Now the region has to be less or equal to, which means it will be the whole of this, right? Now we have to combine those two. As you can see, has to satisfy those two. So combining those two, let's see what we have to shade. So let me try to draw this kind of correctly now, just so you have an idea. So I will have to first draw my real axis and my imaginary axis. Okay, so that will be the real one and the imaginary one. Now, let me try to find a few points. So this is my, let's call this 1, minus 1. And here we have I and minus I. The first point is minus 1i. That should be somewhere over here. And of course, we have to try your best to draw this circle, right? Let me first measure the radius of 1. Now again, you can just freehand this. It is only sketch. However, if you would like to also use the compass, you can always do that as well, so you can have something pretty accurate. It's up to you. If you have time, obviously, you know. But if you don't have time, you can free draw this with your hand. Doesn't need to be exact. Now, obviously, you should not draw a square, right? If that makes sense. Okay, that will be the first one. And then the other one will be from this point of 1, 0, that should be here. And that will be joined with 1, 1 because we want to form the angle of 135 from this. So it should be this, joined with this. Now the region where they meet, as you can see, they meet only here. So this will be your answer for the question. Okay? As you can see, when you combine those two, they will meet in that spot. Okay, that will be the answer for your question number 2. Let's move on to question number 3. The variables x and y satisfy the equation this. Great. Okay, now where a is a constant, no big deal. Now part 1, explain why the graph of y against ln x is a straight line, and state the exact value of the gradient. Okay, so pretty easy. So here we have to first express this equation in terms of y against ln of x. So let's try this. At first we have x is equal to a times 3 power minus y. Now, because here we have ln of x, we have to apply ln here and also ln here, because you don't want to change the equation, you have to apply on both sides, if that makes sense, right? Now we can simplify this part. That will be what? Ln of a plus ln of 3 minus y, power minus y. Now the reason why is you have to know your laws of logarithms. Now let's simplify again. We can bring the power here down, right? Here, that will become minus y, ln of 3 plus ln of a, and this will be ln of x. Now we can rearrange. Let's send this over here and this over here. You will have y ln of 3 is equal to minus ln of x plus ln of a. Finally, y will be minus ln of x over ln of 3 plus ln of a over ln of 3. Now let's try to rearrange this. Y against ln of x. So let's make this ln of x here. So you have minus 1 over ln of 3 times ln of x, right, against ln of x plus ln of a over ln of 3. Now by comparison, you do realize that it is same as y equal to mx plus c. When you have y against x, usually it will look like this for an equation of a straight line. So simply you can say by linear law, it shows that it is a straight line. Now we have to state the gradient. Now by comparison, you can see that when we have y against x, m is a gradient. But same thing, when you have y against ln x, this will have to be the gradient. So we have to state, as you can see, so pretty easy. We know exactly where to find this. So the gradient according to the equation have to be minus 1 over ln 3. That will be part A of the question. Now for part 2, it is given that the line intersect the y-axis at the point where y equal to 1.3. So here the axis is what? Let's see. So here we know that it is a graph of y against ln of x, right? We have to know that. Now, we are given the line intersect the y-axis at the point y equal to 1.3. So somewhere over here, there was the line intersect this point. This is the point 0, 1.3. So this is the point, this is the passing point on the line. Now we can use to find some unknown values. Now part 2, we have to find the value of a, giving your answer correct to 2 dB. So pretty easy. Let's use the equation. So our equation is y ln of 3 is equal to minus ln of x plus ln of a. So we have to find the value of a. Now as you can see, because here we have y against ln of x, we know that the first point is what? Instead of x, it is ln of x, and this point have to be y. So just replace in your equation, you will have y is 1.3 ln 3, and ln of x is 0, that will be 0 plus ln of a. So a have to be exponential 1.3 ln of 3. So we have to know this here. So let's say we have ln of a equal to b. What is ln? It is log to the base of e. That will be this. Now for you to find this value of a, we have to send this over here. So a will be exponential b. Same idea here as well. When you have ln of a, to find a, we have to send exponential down here to find this value. So let's find the value now. So 1.3 ln of 3. So exponential that value, that will be 4.17116. Now correct to 2 decimal place, you will write 4.17. Let's try again. Hopefully I don't have the wrong value. 1.7 ln of 3 exponential, the answer that should be 4.17, correct to 2 decimal place. And that will be your question number 3. Let's move on to question number 4. So here we have to use integration by parts. Find the exact value of this integration. So we have limits to 0. Arc of tan is tan inverse of half x with respect to dx or x. So how can we do this? Again, we have to understand what is tan inverse of this. We can also rewrite this as 1 times this. Now by parts, what is the formula we have for by parts? We know it should be uv minus, and this will be v du. So we have to choose which one is going to be u or ndv at first. So we know this have to be obviously u. So u will be tan inverse half x. So we have to find du. So how would you find du? There's many ways to do that. I guess let me go the long way so I can explain the steps, or we can always go the small way. Let's see, the short way. So for example, let's say we had let me make a side note here because I kind of want you guys to know the shortcut as well. You don't need to go the long way all the time. So let's say we have to differentiate d theta to tan inverse of theta. So this will give you actually 1 over 1 plus theta square and multiply by theta, the inside here, prime, the differentiation of the value inside. So that's what usually you will have to get. But let's check if that is actually true. But again, if it's best if you can memorize this for your exam so you don't have to waste time going through all those steps. Again, this, I guess you will learn this in your class as well. But I guess it just takes memorization, practice and all that. Sometimes you may forget. However, this is the main piece here to solve this question. So let me go the long way first. So let's say I can send this over here. That will be tan of u equal to half x. Now x is equal to 2 tan of u, right? Now I know this, we can do dx by du, right? So you will have 2 is 2, tan u, that will become sec square u. Because we have to know differentiation of tan is sec square u. Now, something happened here is that we have to understand we can use the formula that we have in our list. It is what? Because we know first is sine square u plus cos square u has to be 1. But from this we can derive another one. If you divide cos square everywhere, you will have tan square u plus 1 equal to sec square u. Now we can replace this by this because sec square u is also equal to this. So you will have dx by du have to be 2 times tan square u plus 1. Right, but now we know what is tan square u. Tan u, for example here, tan u is equal to half x. But now from this tan square u have to be 1 over 4 x square. So you will have 2 times 1 over 4 x square plus 1. We can simplify. That will give you what? Half x square plus 2. Right. Now we can again simplify again. Let's have a base of 2 everywhere. You will have 2 here. That will be x square plus 4. That will be dx by du. Now from this we can derive what? Du by dx will be 2, because dx by du is this, but if you flip this over, du by dx will become 2 over x squared plus 4. And that's what we are trying to find, right? Du by dx in the first place. Now again, if you go back to using I guess your formula, we can also find this. For example, let's use this directly. So here we have this one. U is equal to tan inverse of half x. Now what is d by du? So respect to du. That will become 1 over 1 plus theta square is this, theta square, that will be 1 over 4 x squared multiplied by this, which is the d by dx of this will be half. So let's see what will that give you. So simplify. So let's first simplify this. So the base will become, that will be 4 as common, and you will have 4 here plus x squared. That will be half. Now we can rearrange this one. We have to bring this up, right? That will be 4 here, and that will become 4 plus x squared times half. And this will cancel out. You'll have 2 here. And finally, you will have the same value as well. But at least now you guys know how can we also do this step by step, and how we can just use the formula directly to find the same thing at the end. Okay. Now we have u and du. We have to find v. Obviously, dv will be what? Will be the value of 1. So dv is 1. So v will be 1. That should give you, of course, with respect to x, that should give you x. Now we all have to do is to replace back in the main equation, which is the one we have to use for biparts. So that will be u. U was found to be tan inverse of half x times v. V is x minus integration of v, which is x, and u is du. Du is found to be 2 over x squared plus 4 dx. Now we can simplify. First, let's try to just solve this. So as you can see, this can be done by substitution, right? If you think about it, it's possible. Let me show you guys. Because we have d by dx of the base in the other one, we can use substitution. But let me show you step by step, because I don't want to confuse anyone in this question. So here we will have 2x on top, and then at the bottom we will have x squared plus 4 dx. Now, because we have d by dx of the base will give you 2x, and we have 2x here as well, so we can see we have 1 in the other, we have x at the base, and we also have x at the top. It will help us to kind of eliminate each other. But let's proceed step by step. So first, we call this, let the t be the base, x squared plus 4. So dt by dx will be what? Will be 2x. Now from this, dx will be what? Dt over 2x. Now replace back in the main equation. You will have, on top you have 2x, right? The base is now t. Dx is equal to dt by dx. So by 2x. Now you can see these two will cancel out. So you will remain 1 over t with respect to dt. So that is simply ln of t as your answer. So pretty easy. Replace t by the main formula here, which is ln of x squared plus 4. Okay, so integration of this will give you this, as you can see by substitution. Let's rewrite this on the main page. So from this we realize we get x tan inverse half x minus, this will give you ln of x squared plus 4. And the limits is what? Given by the question as 2, 0. So 2, 0, that's why 2 here and 0 here. So simplify. So first we have to replace 2 here, that will be 2. Tan inverse of, that will be 1. Minus ln of, that will be 8. Minus, and we put 0 here, that will be 0. Minus ln of 4. So simplify, that's what this will give you what? So 2 times tan inverse of 1 is pi by 4 minus ln of 8 minus is plus ln of 4. So let's see how can we simplify this. So this and this will cancel out. So you have pi by 2. And for this one, it's pretty interesting. If you realize ln of 8 is the same as ln of 2 power 3. We can send the 3 in front, that will be 3 ln of 2. And ln of 4 is the same as ln of 2 power 2. Same thing, we can send this here, that will be 2 ln of 2. So this will become minus 3 ln of 2 plus 2 ln of 2. That will give you pi by 2 minus ln of 2. Okay, this will be your answer, or the exact value of this integration. And that will be your question number 4. Let's move on to question number 5. The complex number u is given by this. Okay. Now, we have to find the 2 square roots of u, giving your answer in the form of this. Great. Where a and b are real and exact. So pretty easy. Let's do that. So square root of u, that will be 10 minus 4 root 6i. We know the answer have to be a real number, so I have to look something like this. A plus bi or ib, whatever. Bi, same thing. Anyways, what will that give you? So let me write this as correctly. That should be, I think I mistyped. It should be a plus bi. So same thing here, should be bi. But anyways, no big deal. Simplify. We have to send the square over here. You will have a plus bi square. That will become a square plus 2abi plus b square I square. That will become a square. Now we know that I square is equal to minus 1, so it becomes minus b square plus 2abi. Right. Now we just compare the coefficients. We have this and this. So comparing the real part compared with the real part and the imaginary part compared with the imaginary part. So we'll have 2 equations. The first one is simple. We have a square minus b square have to be 10. And then we have 2ab have to be minus 4 root 6. Right. Now we have to solve by using simultaneous equation, because you can see we have 2 unknowns. We have 2 equations that we can use. So let's see what can we do first. So I can try to divide by 2. You have 2 here, 2 here. That will become ab is equal to minus 2 root of 6. Let me square both sides. Why not? That will be a square, b square. That will be 4 times 6. That will be what? 24. So I can make a square become subject. So a square will be 24 divided by b square. Right. Now here I have a square. Here I also have a square. So I can substitute in the other one. So you will have 24 over b square minus b square equal to 10. Okay. So now if I want to remove or get rid of this base, I have to multiply by b square everywhere. You will have 24 minus b power 4 equal to 10 b square. Now let's rearrange this. You will have what? B power 4 plus 10 b square minus 24 equal to 0. Now hey, we have a quadratic equation, right? We can factorize. That will be b power 4 is b square times b square. 24 can be what? 24 can be 2 times 12, right? It can also be 4 times 6, right? But now the fact that we want the value of plus 10 here, we have to use, we can use this one or this one. However, because here we have a minus, we'll have to use this one. For example, let me show you guys what do I mean. We'll have to be careful sometime, because if you use this one, I put 6 here, I put 4 here. Now because I have plus, I put plus and plus. You would say, okay, that seems to be plus 10. However, because here we have minus and plus times plus is plus, it will not be good. Factorization. Because if you were to expand this, you will not get back the same thing. That's a problem. So we have to use the other one. B square, we have to use 2 and 12. For us to get plus 10, we have to use plus 12 minus 2. And minus times plus is minus. Here we have minus. It is good. If that makes sense, right? So b squared will be 2 and b squared will be minus 12. Obviously, this is not possible because square of any value will be positive. It cannot be negative. So this is invalid. Now for this one, b can be plus minus root of 2. Now let's move on to which one? To the main question here. So a squared, sorry, b squared is 2. Now a squared is what? A squared can be 24 divided by 2. That should be the value of 12. So a squared, so a can be root of 12, plus minus obviously. But let's simplify this. It could be, so 12 is 4 times 3. Root of 4 is 2. So that will be plus minus 2 root of 3. This is the value of a as well. Okay, so pretty easy. Now we can just replace back. You will have what? U. So the roots of this, the roots of u will give you two values. The first one, a, can be plus minus 2 root 3, and then plus minus root 2 I. That makes sense. You can rewrite them as one by one if you want to. First one is 2 this plus this I, or it could be this one as well. Okay, we have two roots, and these are the values that we have to get, and you have to show your work how you get them step by step. And that will be your question number 5. Let's move on to question number 6. So we have to prove cosec 2 theta minus cot 2 theta equal to tan theta. So we have to make the left hand side become the right hand side. So let's try step by step. So what is cosec? Cosec, we know it is 1 over sine. Sine 2 theta. Minus, what is cot? Cot is cos 2 theta over the value of sine 2 theta. So combine them because we have the same base. That will become sine 2 theta 1 minus cos 2 theta. Now, we have to get tan. What is tan? Tan is sine theta over cos theta. So we have to change that in a way. We have cos below and sine on top. Now we have to use the formulas or the identities that we know to solve this. For example, we know that sine 2 theta is equal to 2 sine theta cos theta. Okay, and we also know that cos 2 theta is equal to what? We can use 2 cos square theta minus 1, or that could be 1 minus 2 sine square theta. Now the reason why we are going to choose this is because on top we need to have sine, so we have to change cos into sine. So that will be 1 minus, so cos will be 1 minus 2 sine 2 theta. And the base will become 2 sine theta cos theta. So let's see what happens. 1 minus 1 is 0. Minus, so let me write this. 1 minus 1 plus 2 sine square theta over the value of 2 sine theta and cos theta. This will cancel out, and then 2 will cancel out. This will cancel out. You will have remaining sine theta over cos theta, and that is exactly tan theta as required. That will be part 1 of the question. Now part 2, hence we have to show that integration of this will give you this exactly. So from part 1 we realized that this value over here will give you tan theta. With respect to this, let's see what happens. Right, so I guess we can solve step by step if you want to, or we can do this directly, but let me show you guys step by step. Why not? So what is tan theta? We realized that we know that tan theta, as we have seen, it is sine theta over cos theta. So let's rewrite this as this. Now again, if you know the answer directly, you can proceed directly, but you can always show step by step of how do you find the answer, right? because we have one in the other, for example, d by dx by d theta of cos theta will give you minus sine theta. Because of that, we can use substitution to solve this question. So let u equal to cos theta. Now du by d theta, that will give you minus sine theta. Now d theta will be du over the value of sine theta. So let's replace. So because here we have changed the limits, we have to we have changed the variable, we have to change the limits as well. Now we have u, so we have u is equal to cos theta. Okay. Now when theta is equal to 1 over 3, u have to be what? Cos of 1 over 3 this. Let's see what do we get. Cos of 1 over 3, so pi over 3. So we have to use radians here. That will be 0.5. And u, and of course we have to also choose when theta is equal to 1 over 4 pi. Again, you have to know the exact values of a few angles because it will help you with showing the exact values of this. Now 1 over 4, what will that give you? So cos of pi over 4 will be this, and I happen to know that cos of 45 is what? It is root 2 divided by 2. Okay, so you have to know these exact values so you can find the exact values as you need at the end of the question. So let me make this down, let me write this down for those who are still learning for the A levels. So the cos, sine, and tan values of 30, 60, and 45, they are important that you know the exact values of those angles. Now again, you will learn them through practice. If you practice a lot, you will of course memorize them over time. Now let's move on to the question. So here you will have what? You have the limits changed. The first is half, root 2 over 2. Here we have sine, and cos, we call this u. Now d theta is what it is? Minus 1 times du over sine theta. This will cancel out. So you will have what? Half root 2 over 2, and you will have minus 1 over u with respect to du. That will give you minus ln of u, and limits half and root 2 over 2. Now simplify. First, let's put in the value. So minus ln of half minus ln of root 2 over 2. So let's see how can we simplify and show this equal to this. So it's not too bad. It is actually okay ish. So that will be what? So minus ln of, what is half? Half is 2 power minus 1. Here we have plus. What is this? We can break this down into ln of root 2 minus ln of 2. Right. Now we can send this over here. That will become ln of 2 plus root 2 is, we have to know it is 2 power half. So we send this on in the front. You will have half ln of 2 and then minus ln of 2. This and this will cancel out, so you will have only this remaining, half ln 2, and this is shown as required as your answer over here. And that will be your question number 6. Let's move on to question number 7. A curve is such that the gradient at a point, so now what is the gradient? We have to know it is simply dy by dx at the point with the coordinates x and y is proportional to this value. Proportional is this sign, and that will be this value y over root of x plus 1. Now again, we do realize that we can rewrite this as follows, right? This can be written as dy by dx equal to k as a constant y over the value of root x plus 1. Right. Now we can definitely bring this down here because again, as you can see, we have to solve a differential equation in this question and then express y in terms of x. And of course, we also have to look out for this information that we have 2 passing points that we can use to find that. So one by one. From the question, we have derived this dy by dx is equal to k y over the value of root x plus 1. Now, we have to set up the equation. So first, let's send this over here, right? You will have, and send this down here, you will have 1 over ky dy is equal to 1 over root of x plus 1 dx. Okay, so now since we have all the x on one side and all the y on one side, we can solve the equation. Okay, so here what do we have? We can just first take out the value of 1 over k. You will have 1 over y dy, and then here you will have what? If you think we can rewrite this as, we can bring this up, that will be x plus 1 power minus half. That will be dx. Now we can simplify. Let's see what can we have for this one. This one's pretty easy. That will be 1 over k, and that will become ln of y is equal to, first we have to increase the power by 1. That will become half, then divide by the same power. And then we have to plus c for the constant of integration. So here we have the equation that we need to solve, or find the values of k and c first, and then express y in terms of x. So we have this right now. Now obviously we have to find this value and this value. Now to find those two values, we have to use those passing points. So the passing point is 0, 1, and then 3. The first one we can use is this one. This is my x value and my y value. So replace, you will have 1 over k ln of 1 is equal to, that will be 0 plus 1 is 1, 1 power half is 1, over 2, over half, that will be times 2. But anyways, plus c. So that will give you, this will be 0, 0, and that will be 2 plus c. So c will be the value of minus 2. Okay. Now let's move on for this one. That will be x and y. Replace, you will have 1 over k ln of e, and that will be, x is 3 now. 3 plus 1 is the value of 4. 4 power half is 2. 2 divided by half, that should be 4. But anyways, let's find the value here. And c is equal to minus 2. So ln of e is 1. So 1 over k is equal to 2 times 2, that should be, so let's do this, and that should be 1. So 2 times 2 is 4, minus 3 is 2. So 1 over k is equal to 2. So k have to be 1 over 2, which is half, or 0.5. You can use this or this, it is up to you. Now let's rewrite this, everything down to our main equation. So we have 1 over k at first. So 1 divided by half will be 2 ln of y is equal to 2 root of x plus 1 and minus 2 for the value of c. Now here we have still to express y in terms of x. So we have this first. Divide by 2, you will have this plus 1 minus 1, and y will be exponential x plus 1 minus 1. And this will be y in terms of x as your answer, solving the equation and expressing y in terms of x. And that will be your question number 7. Let's move on to question number 8. The equation of the curve is given by y equal to this for this domain. Now what are those values? So what is pi divided by 2? That will be, on one side we have minus 1.57, and here we have 1.57. So x will be between those values. Okay, great. Now question, we have to find the x values of the stationary points of the curve. So first thing, we know we have more than one because there's points, and then we know this happens when dy by dx equal to 0. So let's find that. We have to find dy by dx from this equation. So how do we find this? We realize that this is made up of two functions multiplied together, so we have to use the product rule. So dy by dx will be what? First, leave this one the same as it is, then multiply by d by dx of this one. That should be 2 tan x, and then multiply by sec square x. Then plus, leave this one by itself, tan square x, then multiply by d by dx of this one. That should be exponential 5x multiplied by minus 5. Simplify, that will give you what? 2 exponential minus 5x tan x sec square x, and then plus or minus exponential 5x tan square x. Now obviously here we can factorize a few things. If you realize this is the same as this and this is the same as this, so let's factorize one by one. So first we factorize minus 5x, exponential minus 5x. Then we factorize tan x. Remaining you will have 2 sec square x and then minus 5 tan x, right? So we have this as your dy by dx. Now we are trying to find the stationary points. Here we have dy by dx. We have to equate that to 0, right? For now everything is okay still. Now we can try to simplify this first as well. So we realize that according to the formulas we have or the identities, it will give you that 1 plus tan squared x is equal to sec square x. So from this I can have 2 plus 2 tan squared x minus 5 tan x is equal to 0. So simplify, you will have 2 tan squared x minus 5 tan x plus 2 have to be 0. Simplify, we can factorize obviously because this one is a quadratic equation. So you have this 2 brackets, we have 2 tan x, and here we have tan x as well. 2 is 2 times 1. To get minus 5 we have to have minus 4 and minus 1, right? Because we always multiply this by the last one and this by this one. So 2 tan x multiplied by minus 2, that should be minus 4, and then minus 1, that should be minus 5. And again, minus times minus is plus. This is good factorization. So tan x is equal to half, or tan x can be the value of 2. Okay, great. Now this will be derived from this part. How about the rest of those two? Let's see if we have any other solutions. This one is we have exponential. Minus 5 is equal to 0. So minus 5x have to be ln of 0. Now we can check, but that is not possible. As you can see, this will not be valid. So this will not be a good solution. How about this one? Tan x is equal to 0. Now x could be what? Tan inverse of 0. That should give you what? Let's check. We have to use radians here, 0. That will be 0. That's one of the possible value. And also the other one will be pi plus 0. That should be pi. But here we have to write down the value correct to 3 decimal place. That will be 3.141. So that should be 2. That should be the other value. Now, for now, let's just write this down and then move on with the question. So, how about this one? We understand it is positive value. It will have to be in the first quadrant and in the third quadrant. So this is simply the value directly. X will be tan inverse of half. That will be what? That will be 0.464, or it can be the value of in the third quadrant plus pi, that should be 3.605. And for this one, same idea, x could be tan inverse of 2. So tan inverse of 2, that should be 1.107, or it could be plus pi, that should be 4.249. Okay, now we have to check. Are these values inside the domain that we need them to be? So we have only the values between minus 1.57 to 1.57. So 0 is in between. Yes, it works out, but this is too much. This is okay, but this is too much. This is okay, but this is too much. So we end up with only 3 values, this, this, and this. X can be 0, 0.464, and 1.107. Okay, so here you can see they were asking you for the x coordinates only. So we have those x values correct to 3 decimal place. Okay, so here you go. That should be your answers for question number 8. Let's move on to question number 9. So here we have let f of x equals to this function. Part 1, express f of x in partial fractions. So let's first begin with let f of x equal to what? F of x equal to, because here the factor is linear, we can write a over 2 plus x, and here we have the plus, and because here it is a quadratic factor, we have to write bx plus c over 3 plus x squared. Now, so linear here just means the power of x is 1, and quadratic, it means the power of x is 2. That's what it means. That's the first step. Now, obviously, f of x is equal to this as well. We have to kind of multiply the base up here, so by these fraction. Let's see what you will have. So eventually, by doing that, you will have this. On one side, you will have 14 minus 3x plus 2x squared is equal to a. So a over this multiplied by this will give you a times 3 plus x squared. And then b over this multiplied by the base, that will give you bx plus c. And here will be the value of 2 plus x. Okay, that will be this. So right now we have this equation we have to use to find the values of a, b, and c. The first step, I can first change this to 0 by taking the value of x to be equal to minus 2. So let's do that. When x equal to minus 2, this will be 0 here, right? Because 2 minus 2 is 0. That will be 0 everything. And here what you will have, let's see one by one. You can of course use your calculator to find out the value on the left hand side first. So we have 14 minus 3 times minus 2 plus 2 times 4. You will have 28 on one side. So let's write down the value here, 28 on the left hand side. And here what you will have, this will be 0 obviously. And 3 minus, so we have plus 2 squared is what? So 3 plus 2 squared, that will be 7. So you have 7a, which means a will have to be 28 divided by 7. That should be 4. So a will be the value of 4. Now let's move on to the next. We have to find the value of b and c. So let's begin with the value of x. So we can choose x to be anything. So let me choose x to be, let's say x equal to 0. Why not? Because it is easy to work with that value. That's the reason why. So on the left hand side you will have 14. And here you will have, this is 4 obviously. So we have 4 times 3 plus 0, that will be 3. And then plus b times 0 will be 0 plus c. So here we have, this will be 12. Plus, that will be 0 here, that will be c. And this will be 2. So here you can see 2c will have to be the value of 2. So finally, c will have to be 1. So a is 4, c is equal to 1. Now we have to find the value of b. The next value we can work with, what is after 0? We can just work with x equal to 1. So the left hand side will be 14 minus 3 times 1 plus 2 times 1 squared. That should be 13. So 13 will be on the left side. E is equal to, that will be 3 plus 1 squared is 1. That will be 4 times a. A is equal to 4. That will be 16. Then plus, here we have b times 1 is b. Plus c, c is 1. Times the value here, 2 plus 1 is 3. Right. So you will have 13 minus 16 will be minus 3 is equal to 3 b plus 1. So b plus 1 is equal to minus 1. From this you can see b will have to be minus 2. So in the end, since we have found the value of a, b, and c, we realize that f of x can also be what? B equal to, a is 4, so 4 on the value of 2 plus x, and plus here. Now because b is negative, I can write b afterwards. C is 1, so that will be 1 minus 2x over the value of 3 plus x squared. That is part 1 of the question, expressed in partial fraction. Now for part b, hence obtain the expansion of f of x in ascending powers of x up to and including the term in x squared. So let's have a look at these two fractions one by one. Let's first try to expand this one. So let's call this number 1. If you observe, this is 4. Let's bring this up. That will be 2 plus x power minus 1. Now, as we know, for the formula we have to use, this is 1. So we have to change that into 1 by factorization. So that will be 4 outside, factorize 2 outside, that will be 2 power minus 1. That will be 1 now, and that will be x over 2, that is half x, and that will be minus 1. Now, 2 power minus 1 is simply half. 4 times half is 2. So that will be 2, 1 plus half x power minus 1. So we have to kind of expand this up to and including the term in x squared. Now, how do we expand something like this? It is given to you on your formula. You have to know. So let's continue up here. That will be 2 is outside. The first term obviously is 1. Then we have n. So this will be your new x in the equation, and that will be your n. N will be minus 1, and x will be minus half x. Right. And then plus, we have minus 1. We have to minus 1 again, that will be minus 2, and that will be minus half x squared over the value of 2 factorial. So we can stop right here because we don't need more than this. We just need the value up to and including the term in the x squared. That will be 2, that will be 1, that will be plus half x, and that will give you what? So this will, the minus sign will cancel out, that will be 2. So you have plus 2 times 1 over 4x squared over the value of 2. Right? Because 2 factorial, we can check. 2 factorial is just 2. So this and this will cancel out. So you will have 2 times 1 plus half x plus 1 over 4x squared. That will give you 2 plus x plus 1 over 2 x squared. So this is the first expansion for this one. So now obviously we have to find this one. Right. So let's first ignore the top for now. Let's find the expansion of this one. If you were to bring this up, let's say we have 1 over 3 plus x squared, same as 3 plus x squared power minus 1. But now again, because we have 3 here, we have to make this become 1. We have to factorize. You will have 3 power minus 1. That will be 1 plus 1 over 3 x squared. That will be minus 1. Now this is simply 1 over 3. And the rest here we have to use the formula we have. Again, that will be 1 plus minus 1 times 1 over 3 x squared. And then plus minus 1 times minus 2. 1 over 3 x squared over the value of 2 factorial. Again, how do I know this? It is just a formula we have to use for this kind of expansion when the power is negative or a fraction, and we have to simplify one by one. So let's see what can we do here. That will be the same, and here we have 1. That will be minus 1 over 3 x squared. Here you will have, this will cancel out again. That should be plus 2, and that will be 1 over 9 x power 4 over the value of 2. Now again, we don't need anything in x power 2, so we don't need this term. We need only the term up to including x squared. So let's just keep this until here. So we have 1 over 3 minus 1 over 9 x squared. So we just need these two terms from that expansion. Now again, we do know that we have bx plus c on top, which is 1 minus 2x. So we had this before, so this can also be written as what? It can be 1 minus 2x is 3 plus x squared. But now we realize that this term here, so this term here could be 1 over 3 minus 1 over 9 x squared. That will be the same thing as 1 times this. You will have this first, right? And then this you will have minus 2 over 3x. Here if you take this time, this will be power 3. We don't need that. We just need this one. Okay, so that will be 1 over 3 minus 2 over 3 x, and minus 1 over 9 x squared. Okay, so we have this one, which is this, and we have this one, which is this. We have to add them together, right? So let's see. F of x will be what? Will be 2 plus x plus half x. That is the first one, right? This one. And we have to add this one. That will be 1 over 3 minus 2 over 3x minus 1 over 9 x squared. Let's see what do we get. So 2 plus this will be what? That will be, we can write 2 and 1/3, or if you want to, we can break this down as well. 2 times 3 plus 1 will be 7, 7 over 3. And x here we have 1 minus 2 over 3 will be 1 over 3. And half minus 1 over 9. That should be 7 over 18. 7 over 18 x squared. So f of x could also be this up to the term in x squared. And that will be your question number 9. Let's move on to question number 10. So the diagram shows the trapezium ABCD, in which AD is equal to BC, so this and this are the same, and this whole thing is 2R, right? And then here we have arcs of circle, center A and B respectively, and the angle here is x. This is given to you. Now, M here is the midpoint of AB. Now let's move on to part A of the question. Given that the sum of the areas of the shaded sectors is 90% of the area of the trapezium, we have to show that x satisfies this equation. So pretty easy. So we are given that the shaded area is equal to 90%, which is 90 over 100, of the area of the trapezium. So we have to find those two. We have to find this and this to satisfy this equation, to show this is true. Let's go one by one. How would you find the area of the shaded region? So pretty easy. As we can see, it is two of the same sectors, right? Because they have the same radius and the same angle. So pretty easy. Area of sector is what? It is half r squared. The angle is x. Now we have to multiply by 2 because we have 1 and 2. That will be r squared x. So let's do this. That will become r squared x is equal to 0.9. Now for this part, what can we do? What is the formula for area of a trapezium? So as you guys should know by now, area of a trapezium is what? It is equal to half times the sum of the parallel sides, which is AB plus DC, and then multiply by the perpendicular height. So we don't know what is the height yet. So we have to find these values to find the area of trapezium. So AB is pretty easy, given to you as 2R, right? AB, R plus R. Now what is DC? DC is this one. Okay, so we have to find this. And we also have to find pH. pH is the vertical height. So let me just do this so we can find a way to find those values. What if I join the vertically with the line AB? You have 90 over here. You have a right angle triangle. Now, let's take out the shape and see what can we do. So you have this, this, and this. That will be A. Let's call this point, let's call this E, why not? And let's call this D. So here we have X, here it is 90, and the value here is R. So first we can find the value of height. We can find the value of the height, right? This is the vertical height, this is the perpendicular height. Let's find that first. Now as you can see, we have a right angle triangle. We can use SOHCAHTOA to find this. We have this side, we want to find this, we can use sine. So sine of the angle is equal to the opposite side, h, over this is the hypotenuse, which is r, right? So h have to be r sine x. That is my height, which is r sine x. Now we have to find DC. Now, how can you find DC? Let's observe. We have to break this down into a few pieces. For example, to find DC, I can first find this one, right? Now, to find this length, I can find this length and take the whole thing minus this to get this. Okay, so let's first find this one. Let's call this length, let's call it y. Let's find y. Now we have this, we have this, we have the angle, we have to find y. We have to use SOHCAHTOA. So that will be using cos of the angle. That will be my a side over h side hypotenuse. Sorry, this is r actually, not h. So y will be simply r cos x. So the length here is r cos x. So finally, we do realize that this length over here is what? This whole thing is r, right? So this will be r minus r cos x. That is only this part, right? So to find the whole thing DC, we have to multiply by 2 because we know this is the same as this, right? So now next thing, we just have to replace back in the equation. That will be half. And then we have, this is 2r plus 2 times r minus r cos x times r sin x. So let me bring this down and simplify this, if I can do that. So that will be half here. I have 2r plus 2r minus 2r cos x multiplied by r sin x. Simplify. So here I can factorize 2 outside, so 2 will cancel out with these 2. So you will have r plus r will be 2r minus r cos x multiplied by r sin x. Now if you realize, here we have r and r, we can factorize r outside. You will have 2 minus cos x times r sin x. And we can take out the r2 here. So take out the r, you will have r squared. And that will be 2 minus cos x and then sin x. So let's bring this on top. Here you will have what? R squared multiplied by r squared times 2 minus cos x multiplied by sin x. So this and this will cancel out. So finally you will have x is equal to 0.9 times 2 minus cos x sin x. This is shown as required. And this is your question, part 1 of showing this is equal to this. Now let's move on to part B of the question. As we can see, as we have already, x is equal to 0.9 2 minus cos x sin x. Now we have to verify by calculation. X lies between those two. Now exactly between what value do we have? We have the value of 0.6. Okay, so let's find the value of this x when the value of x here is, so here we have 0.5 and compared with 0.6 and 0.6 compared with 0.7 to see if the sign changes. When x is equal to 0.5, let's see what do we have. 0.9 times 2 minus cos of 0.5 times sine of 0.5. That will be 0.484, okay? And 0.6 will be what? 0.9 times 2 minus cos of 0.6 times sine of 0.6. That will be 0.597. Obviously this will be the same as well, 0.597. And what is this one? So here we have 0.7, so 0.9 times 2 minus cos of 0.7 sine of 0.7, that should be 0.716. As you can see clearly, here we have, this is, so 0.6 is more than this, so let me write this down again so we can compare correctly. So we can see 0.6, so let me rewrite this down. Here we have 0.5. 0.6 is 0.597. Here we have 0.484. As we can see, this is more than this, but this is less than this. So because there's a change in sign, or if you can just do difference as well, you will see there will be a change in sign. We conclude that x lies between 0.5 and 0.7. Okay, so now part C. We have to show if a sequence of values in the interval 0 and half pi given by the iterative formula converges to the root in part 1. So pretty easy. Let's say we have x here, that will be cos inverse. So we just have to show this formula will give us back what we had in the first place. So pretty easy. We send this over here, you'll have cos of x. That will be 2 minus x over 0.9 sine of x. We can send this over here and this over here. You will have x over 0.9 sine x. That will be 2 minus cos x. So finally, x is equal to 0.9 times 2 minus cos x times sine x. This is shown as required as the equation in part 1, right? This is part C of the question. Now, finally, we have to use the formula we have been given, which is x n plus 1 is equal to cos inverse 2 minus xn over the value of 0.9 sine of x n. Use this to find x correct to 2 decimal place. Give the results of each iteration to 4 decimal place. So let's find out. Okay. So let's see, what do we have here. So first thing first, we know that x1, let x1 to be the middle value, which is 0.6, as we have seen here, right? The middle value is 0.6. What is x2? Okay, so let x1, which is first answer, that will be 0.6. Then we have x will be cos inverse of 2 minus answer divided by 0.9 sine of answer. That will be this. So that will be 0.610506 x3. That will be 0.6151 x4, 0.6170 x5, 0.6179 x6, 0.6182 x7, 0.6184 x8, 0.6184 and x9, 0.6185. Now of course you can keep going on. So the idea here is you want to show you have done enough iteration so that you don't need, you have proven your answer converges to a point that you don't need any more iteration. Again, you just have to show you did enough iteration, and then you can just choose correct your 2 decimal place, sorry, for your answer. That should be 0.62 for your answer. And that will be your question number 10. Let's move on to question number 11. So with respect to O, the points A and B have position vectors given to you by these two. So which means OA is equal to 2 minus 1, 0, and OB is given to you by 0, 1 minus 2. Okay, so let's see, what do we have? Part 1, we have to show the length of OA is the same as OB, so pretty easy. What is the magnitude of OA? That will be root of 2 squares 4 plus 1 square, that should be root of 5. And the magnitude of OB, same steps, that will be 0 plus 1 plus 4, that will also be root of 5. Conclusion that OA is indeed equal to OB, but is for first part of the question. Now part 2, we have to use scalar product to find the angle AOB, so pretty easy. So we know that it has to be OA dot of OB dot product is equal to magnitude of, say, OA times OB, and then the angle in between will be angle O right here. Now this we know already. It is given to you by 2 minus 1, 0, dot of OB, 0, 1 minus 2, and this is root of 5 times root of 5 cos of the angle O. This is scalar product, so 2 times 0 is 0. This will be minus 1, and that will be 0. That will be 5, and that will be cos of the angle. So cos of the angle will be minus 1 over 5. So the angle will be cos inverse of minus 1 over 5. Cos inverse. So here we have to provide the answer in degrees. That will be 101.5 as your answer for question part 1 of 11. Now let's move on to part B of the question. So here we have the midpoint of AB is M. Okay, great. And the point P is on the line through O and M is such that the ratio of PA and OA is root of 7 to 1. Now using that information, we have to find the possible position vectors of P, so which is we have to find the possible values for this vector OP. Now let's write down the information that we have from part 1. Now part 1, we know OA has been given to you by what? By, so here we can see it is 2 minus 1, 0, and OB was given to you by 0, 1 minus 2, those two. Now AB, we have to find AB, right? So what is AB? AB will be OB minus OA. So let's find that. That will be OB is given to you by 0, 1 minus 2, and OA is 2 minus 1, 0. 0 minus 2 will be minus 2. 1 minus minus 1 will be 2, and this will be minus 2. Now the midpoint, so if you understand, we have, for example, we have A and B, and the midpoint here is M. So here we can first find AM. What is AM? AM is halfway AB, which is half, times AB. That will give you half of this value. That will give you minus 1, 1, and minus 1. Right. Now using that value, AM, we can try to find OM. How? We know by definition, AM is given to you by OM minus OA, right? That will be minus 1, 1, minus 1. Now, OM is going to be minus 1, 1, minus 1, plus OA. OA is given to you by 2, minus 1, 0. This is going to be minus 1 plus 2 is 1. 1 minus 1 is 0. Minus 1 plus 0 is minus 1. So here we go. We have our first vector here. OM is given to you by this. Great. This is why we had this information, is to find the value of OM. Now let's move forward with the rest. We have the point P is on O and M, on the line OM through OM, such that the ratio of PA, the length of PA, against the length of OA is given to you by root 7 to 1. Now, in part A, we have found the length of OA was what? As we have seen from part 1, is showed to be root of 5. So which means, if this, so let me just try to explain to you how we can find the length of PA. So here the ratio is, the ratio of P to A is given to you by root of 7 to 1. Now we know the length of OA is given to you by root of 5. You will have root of 5 is equal to root of 7 to 1. So which means we can cross multiply. PA will be root of 7 times root of 5, which is simply root of 35 PA. So the length of PA, which is the magnitude of PA, is given to you. So we have to find a way to use this. Right. Now, one thing is we can form here is, from this thing, we are told that we have, let's say we have the line through O and M, and P lies on that line, right? We're told here, P lies on the line through OM. So let's say P lies over here. Now, when we have three collinear points, we can form an equation. As you guys know, we can write, for example, OP is equal to a multiple of OM. Because the reason why we can write this is because they lie on the same line. OP and M, they are collinear points, and we can write this kind of equation. We can write OP is equal to KOM. We can write, for example, PM is a multiple of OM. We can write many variations, but this is one of the examples we can write. In this case, that is useful. Why? We can just replace OM by something we know already. That's why I chose this one. That will be K0 minus K. That will be OP for you. Now, we know the magnitude of PA is given to you by this. Now, what is PA? By definition, PA is OA minus OP. Now, we don't know the value of P yet, but we know A is given to you by 2 minus 1, 0. Minus OP, OP is K, 0 minus K. That will be 2 minus K, minus 1 minus 0, and then we have plus K. So we realize that PA is going to be what? 2 minus K, minus 1 and K. So what is the magnitude of PA? Let's find out. That will be root of the value here, 2 minus K square, plus minus 1 square is 1, plus K square. And we know this is equal to root of 35. Now we have to simplify. So this and this will cross out. So you will have 2 minus K square plus 1 plus K square equal to 35. Now let's expand this one. That will be 4 minus 4K plus K square plus 1 plus K square equal to 35. Now let's try to simplify this. This plus this, that will be 2K square. Here we have minus 4K, and 4 plus 1 is 5, and we send this over here, becomes minus 35. That will be 2K square minus 4K minus 30 is 0. Okay, now because everyone is even here, we can divide everything by 2. That will be K square minus 2K minus 15 is equal to 0. Now we can just try to factorize this. That will be K times K. 15 is 3 times 5. To get minus 2, we have to have minus 5 plus 3. Okay? Now finally, K can be the value of minus 3, and K can be the value of 5. So we have two possible values of K, 3 and 5. So from this, obviously replacing OP can be what? Can be K, 0 minus K. So first value will be minus 3. So minus 3, 0, 3. Or it can be 5, 0 minus 5. Okay, so this one was the last question of this paper. I hope that was somewhat helpful. If you guys have any questions, you guys can leave me a comment down below. With that being said, thank you for watching. I will see you soon.